friends, today I'm going to solve LeetCode problem number 373, find k pairs with smallest sums. So in this problem we are given two integer arrays nums1 and nums2, and it is sorted in ascending order, and we are also given an integer k. Now here what are we going to do is we are going to form pairs where u is from the first array, that is nums1, and v is from nums2, and we are going to form k such pairs, and those k such pairs should have smallest sum. So u1 plus v1 should be the smallest sum, u2 plus v2 should be the second smallest, and so on. So basically we need k such sums whose sum of the pairs is the smallest of all of the others. Okay, so let's look at this example here. So what are we given is, let's take this over here and look at the example. All right, so we are given nums1 and nums2, and the value of k is equals to 3, which means that we need 3 such pairs with the smallest sum. Now since we already know these two array are sorted in ascending order, so the first two will always be the smallest number, which means that the first two of these elements will always be the smallest sum. So if we take the pair 1 2, the sum is always going to be the smallest, which is equals to 3. Now let's take the next pair. So if we take 1 and if we take 4, that would also be the smallest one, right? Because it equals 5. Now like if we are taking 7 and 2, that's equals to 9, which is greater. So instead of taking 7 2, what we do is we take 1 and 4. Now we are also taking the sum 1 and 6 here. So let's see here, 1 6, and this gives us equals to 7, which is again smaller than 7 and 2, right? So basically what are we doing is we want the smallest sum, so we are taking the sum of 1 and 2, sum of 1 and 4, sum of 1 and 6. We are also taking the sum of 7 and 2, 7 4 7 6, and so on. So if you were to perform brute force, we would take each of the elements from here and take sum with each of the elements over here, and then find the smallest k element. So for that basically we could use mean heap. Okay, so let me just show you over here so that I can draw the solution and it would be easier for you to visualize. So let's look at the brute force solution. So here we have 1 7 11, and next we have 2 4 6. Okay, so if we are to form pairs, basically in brute force we will take 1 2 1 4 1 6, right? So that will give us pair 1 2 1 4 and 1 6. Now we have these pairs. In the next step, what we'll do is, next we'll take other pairs 7 2 7 4 7 6. So now when we are taking the next pair, that is 7 2 and 7 4 and 7 6. And then similarly we are going to do with 11. So we are going to take the pair with all of them. Okay, so 11 2 11 4 and 11 6. So basically we are taking each of the elements and taking pair with each of these. So this would be n times n. Okay, now we also need to get the smallest one, right? So this is how we actually form pair. Now we need the smallest one, so we could actually use mean heap for that one. So what does mean heap do is, the top root will always have the smallest value and the rest of the nodes will be larger one. So if we do mean heap, then the minimum sum of all of these would be equals to what is it, 3, right? This will have the minimum sum, so this will be at the top. So basically we could dequeue this top value and then we can add to our result the pair, so we would know that this is our result. And then similarly next, this would be our least smallest, right? So it will always be on the top. So basically we need a mean heap, to find the minimum one. Okay, so now this here we are doing n by n times. So now is it necessary for us to do it n by n number of times to find the minimum? Let's look at this example one more time so that we can optimize our solution. So okay, so here we have 1 and 2. Let's take the first two. So the first two will always have the least sum. Why? Because these two are the least of all the elements, so these two sum will always be the smallest. So the first two, we always take the first two and we are adding the sum to our queue. So the sum is equals to 3, so we are adding this to our queue. Okay, okay, let me write it this way. So we actually do not even need the sum, we are just going to insert these two pairs and the index of this one. So I'm taking 1 and 2 only, so the index is equals to 0. Now next what I'll do is I'll move to this next value, which is 7, and I'll only compare it with 2. So I'll only take the pair with the first element in the second one. So 1 with 2, then 7 with 2, so that would be 7, 2, and the second index of this at the second array, which is 0. We are only taking index 0, right? And now 11, so 11 and then 2 and then index 0, right? So now among these, obviously this is the smallest one, so we'll get the mean value from our mean heap, because like we have already inserted this in our mean heap and compare the values. Okay, so once the mean heap is now created, what we do is next we have 1 and 2. Now what we need to compare 1 with 4 as well, right? So we pop this out, we enqueue this from our priority queue, from our mean heap priority queue, and then now we look at this index is equals to 0. So since this index is equals to 0, which means that I'm comparing my element from the first array with the element at index 0. Now I also need to compare with the next element, which is 4. So I now enqueue 1, 4, and the index of 4, which is 1. Okay, so now that I have added to my queue, now my mean heap will have this value as the minimum one. Okay, so in the next step what happens is when I enqueue this, I will have the index 1. So this one index will be as the minimum. So we have 1 4, we have 1 1 2 and 1 4. Now the next minimum value would either be 1 6 or it would be 7 2, right? So since I found 1 4 as the minimum, so next what I'm going to do is I'm going to enqueue 1 with the 6, that is the next index in the array 2, right? It's at index 2. So now enqueue this one. Now among the rest of the values, that is these values in my priority queue, which is the smallest one, this is the smallest one, right? So I enqueue this, and basically I'm enqueuing it, I'm adding all of these to my resulting array while I'm enqueuing those. And when my resulting array length is equals to k, that is when I stop enqueuing, because I already have the result, and that is when I return my result. So in summary, let me summarize here once again what I am doing. Okay, so what are we doing is, first of all, we always compare 1 to 2, because 1 2 will always be the smallest one. The first two elements are always smallest, so the sum will always be the smallest. So we take these one. Now we could either take these two or these two, right? So among these two, which will be the smallest one? Of course it is 1 4, right? So that is why we take 1 4. So now that we have taken 1 4, now the smallest one who could be either these two or these two, right? We already have these values, so that would be either the smallest value in this and the next smallest here, which is 6 because we have already taken that, or the second smallest and the smallest one here. So between these and these, so of course here 1 and 6 is the smallest among between 7 and 2, so that is why we take 1 and 6. So that is how we are actually doing it. So let me just take another example here. So I'm just going to make few changes to my example. Okay, so now that we have these example, so I have 1 7, I'm just going to paste it over here, and the next one is this one, so I'll paste it over here as well. So now we have these two arrays. Okay, so how are we now going to perform our queue function? Okay, so as we already know that the first two small are always smallest, so we already have 1 and 2. Now next we would take either 1 and 10 or 7 and 2, right? So we are basically 1, we have 1 2, now we are only incrementing this index, right? This index, and this 7 and 2 we already have it in our list. Also 11 and 2 we already have it in our list. So now between these two, which is the smallest, 1 plus 10 11, 7 plus 2 is 9. So here I take 7 and 2. So now in this case, now 7 and 2 was taken, so the next index would be 7 and 10. Okay, now between 1 and 10 and 7 and 10, which is the smallest? 1 and 10 is the smallest, right? So I take 1 and 10 as the smallest one, which is equals to 11. So now my next comparison would be between 1 and 11 and 7 and 10. So between 1 11 7 10, which is the smallest one? 1 11, right? So I'll take 1 11. Now since I'm done with the index for 1, so in the next step now we have 17, right? And now we have in the array, I mean in the priority queue, we already have 11 and 2, so we are actually comparing now 17 with 11 and 2, and between these two, which is the smallest, 11 plus 2 is equals to 13, 7 plus 10 is 17, so basically 11 and 2, right? So this is how we would be performing our operation, and for that we already have like inserted each of these elements which is of the first one, and then now based on which element we took, did we take this one? If yes, then now we are going to increment it. We are going to take the next value and then compare that next value with the remaining with 7 and 10 and so on. So that is how we are doing, because like as we know, as we could see, like it only matters like in this way, like 1 10 7 2 only cross sectional wise. So that is why we are performing it in this way. So now that we know how to solve this problem, let's start coding. So for that, what do we need? We need a mean priority queue, right? Mean priority queue, we need a list, we need an array list to store our result, and that's all that we are going to need. So let us first create a mean priority queue. So priority queue equals to mean priority queue, and then here we are going to perform our comparison operation. So compare we compare, and here what we are comparing is between the two elements in our list, in our priority queue. We take the sum of a0 a1. So a0 is the first element from nums1, a1 is elements from nums2. Okay, and we need the smallest one, right? So b0 plus b1. So between these two we are going to get the smallest one. The compare function will return us that, and now we are going to push to our priority queue. So I less than nums1 length I plus plus, and then priority queue that push, in queue. Okay, so we are going to in queue into our priority queue the value at nums at index I and nums2 at index 0. So each of the element at index each of the element at nums1 with nums0 and the index of nums2. Okay, and now next let us create a result array where we are going to store our result, and now let us iterate over each of the values. So while k is greater than 0 and while our mean heap which is our priority queue is not empty, we keep on performing our iteration. So for that one, now we are going to dequeue. So we need the first element is, let us just write x, y, and the index of I2. Okay, that represents index of the index at nums2 array, right? Which is equals to priority queue dot q dq. Okay, so now that we have the element, we are going to insert to our result, push to our result the value x comma y, because the priority queue will always return the smallest value from when we dequeue, because it is a mean priority queue, right? Now next what we are doing is, if I2 is less than the last element, nums2 that length -1, that is when we are actually going to now enqueue to our mean priority queue. So enqueue. Okay, let me just copy this thing here. So we are enqueuing what? We are just going to take this value only, and now for the nums2 we are going to take I2 plus 1 because we are incrementing our index for nums2 plus 1. So this will basically give us the comparison between like here, as we found the smallest 1 2, right? 1 2 means 2 is at index 0. So next we already have 1 2, we had 1 2 1 7, not 1 7 actually. So next value is 7 2, and the next value is 11 2 in our mean priority queue. Okay, so since we already have these values, we dequeued this. Now we are going to insert a new value. So the new value, the most appropriate candidate is the next index, right? That is the value next to 2. So that would be 1 and 10. So we are taking the same value for nums1, that is x, and for y we are incrementing the index by 1. So that's what we did here. We are taking x as it is and we are incrementing nums2 by 1 index, and that is what we are passing here. And finally we are going to also decrement the value of k. So while k is greater than 0 it will run, and once k is equals to 0 we are finally going to return our result. Okay, so now let's try to run it. Okay, so here's something wrong. All right, now let's run this. Okay, so something went wrong here. Oh, I need this thing here. It's still giving me wrong answer, undefined. What did I do wrong? And then here we are enqueuing this, right, which is nums1 at the index I and nums2 at index 0 and the index of nums2. And then here while k is greater than 0 and the priority queue is not empty, we are dequeuing, and then we push our xy value, and while I2 is less than nums2, okay, this should be nums2 the length because that's from index nums2. This index represents index at nums2. Yeah, now let's try to submit this. Great. So yeah, this is how we could approach this problem using mean priority queue. Let me know in the solution in the comments down below what do you think about my solution. Yeah, thank you.